Okay, welcome to another Spring Showcase. Today marks Showcase 33 for Spring, where we'll be hearing from Xylem about how their innovative Flygt Concertor solution has supported Yorkshire Water in the delivery of their dynamic asset maintenance programme, leading to a reduction in customer complaints and pollution events, as well as improved health and safety across their pumping stations. For those of you who might not already know, Spring is the Innovation Centre of Excellence for the UK and Ireland water sector, and we're here to create centralised intelligence around what already exists in the water innovation space. Our goal is therefore to enable collaboration, remove duplication, and accelerate innovation within the water sector. Before we begin, I just wanted to touch a little on why we actually do these deep dive sessions, like today. So globally, the water sector is under significant scrutiny at the moment, and we really need to accelerate problem solving. And knowledge sharing is one of the ways we can do that. Last year, we partnered with the economic regulator for England and Wales to build a view of what best practice knowledge sharing looks like. We brought together senior leaders and innovation managers to design a vision for knowledge sharing. What is it we're trying to achieve? Ultimately, we want to unlock faster adoption by creating a world-class knowledge sharing culture. So we designed 6 best practice principles for knowledge sharing. Number 1 being learn from what already exists before committing to innovation projects. So Spring is building a centralised source for what already exists so that you can come and check in with us and learn from what is out there before making any investments. Number 2 is target innovation insights to the right audience to meet our objectives. So we want to make sure that the right people are there listening to the lessons. So for today, do we have our data strategists? Do we have our engineers? Do we have our operational teams? Do we have the right decision makers involved in the lessons learned? Number 3 is that insights are regularly shared through multiple channels from day one of the project. Historically, knowledge share has happened at the end of the project, and we want to start moving towards a model where we share from day one. Number 4 is sector knowledge is open and centralised. So we want to make sure that we're all being open and honest when it comes to the knowledge from innovation projects. We want to make sure it's all in one place, i.e. Spring, because fragmented knowledge makes it very difficult to engage with and learn from. Number 5 is insights from both innovation successes and failures are shared. So as we know, the lessons learned from failures are just as important as the lessons of success, and we'll be hearing about some of the challenges from our presenters today. Number 6, finally, is people are empowered to receive and embed lessons from external sources. So Spring and the presenters on this call can all share knowledge, but we want to make sure that the receivers of the knowledge have the resources and the capacity required to make that change, and that they feel empowered to do so. In terms of what will be shared, I would encourage you to look at the Water Innovation Strategy 2050. For anyone who hasn't seen that document, it lives on our website and it outlines 7 main themes with challenges sitting under those themes that we are currently trying to tackle in the sector. We also hosted a webinar about the best practice principles on the 21st of November, which you can watch back on our platform. You can find it under the knowledge section along with our previous showcases and case studies, which will be linked in the chat in a moment. So back to today, I'd just like to give a warm welcome to all the audience members who are joining us live. We are joined by UK and Ireland water companies, supply chain, academia, and lots of overseas colleagues too. So welcome to the call and thank you so much for joining us. We'll be linking a poll at the end of this showcase to find out how interesting you found the information and also whether you are hoping to go away and use it afterwards in your own organisations. So please submit your answers at the end of the event when that comes through. You'll also get the chance to ask the project team any questions at the end of the session, so make sure to keep putting your queries in the chat throughout today's presentation. On to today's session, I'm just going to run through the agenda and introduce our speakers before I hand over to Andrew and Simon. So we'll start with an introduction to knowledge sharing and the context behind the partnership between Xylem and Yorkshire Water. We'll then go into an overview of the dam project and take a detailed look at the Flygt Concertor solution before heading into a short break at 11. After the break, we'll do a deeper dive into the learnings and challenges from the project and finish up with a Q&A session. Speakers-wise, we'll be hearing from Simon Harrington, Programme Manager at Yorkshire Water, Andrew Welsh, Sales Director for Water Utilities at Xylem, Jason Robertson, Account Manager for Yorkshire Water at Xylem. So, over to you, Simon.
Okay, good morning, everybody. I'm Sam Harrington from Yorkshire Water, and I'm just going to go through a little bit of around the importance of knowledge sharing and partnerships. So in terms of our partnership with Xylem, obviously these things are often termed as framework agreements and contracts, but we very much feel that for Yorkshire Water as a business to move forward and help to deal and cover off and reduce our sort of corporate risk, that we need to have these partnerships in place. So we see this as a sharing of not just our own problems, but we're all in it together. We're all trying to make the step change away from where we are as a business and move in the right direction to help to reduce our corporate risk, but also bringing in innovation opportunities. So this particular presentation is all about innovation. It's a game changer in terms of what we've done over the past 3 years. And also, it's a continuation of support. So these are long-term agreements with, other things in place, such as the strategic stock at some of our central locations. That certainly helps us overall throughout the business, and also profitable for the other companies as well.
Okay, thanks, Simon. Hi, everyone. Morning. Andrew Welsh, Sales Director at Xylem. It's interesting, we were talking earlier about what makes an innovation synergy. And, we work in Xylem with every water company in the UK and Ireland around wastewater pumping. And this knowledge share is just so important when it comes to really embedding innovation in organisations. And it's great to have worked with Yorkshire Water, worked with Simon over the last few years on this. Because with their fundamentally huge challenges in AMP8 around wastewater pumping, and without this kind of innovative synergy way of looking at stuff, it's going to be harder for us to really embed good solutions within the water industry. So really, really important that we work together with water companies, work with the supply chain, and we work together, but also to pass that out across the other water companies as well. And that alignment around all of the stakeholders within a water company and supply chain, we found to be really, really important to be able to get to this stage where we are today with Yorkshire.
Absolutely. Just moving on to wider knowledge sharing. So in the water industry, we've got quite a competitive environment that has been brought in, mainly driven by Ofwat. They wanted competition between the businesses to help us improve our performances. But it's not generating the right sort of cultures that we need to move forward as a business and as an industry. So instead of trying to get that competitive advantage working in silos, we're now having far greater collaboration with our WASCs and suppliers. That gives us confidence that we're doing the right thing, because we're having open and honest discussions with the wider water industry. And it's great to see that we're all heading in the same direction. Some at different pace, some doing things slightly different, but it's great to speak to people, gain understanding about the issues and how they're dealing with them, and look to see if we can sort of cut out and reduce those mistakes, but also gain efficiencies from how we go about delivering programs of work such as this. The other good point is, by taking that lessons learned, information from these other parts of the industry, we can expedite return on investment, which is a benefit not just for ourselves, the environment, but also our customers and suppliers as well.
Okay, so just to give a bit of context and background around the using Concertor from Yorkshire Water, during AMP7, we work with every water company with wastewater pumping frameworks. And in AMP7, the real drive was 100% availability, okay? So what we were providing to water companies was really that ability to have stock, have equipment when they need it. We do it in various different ways for different water companies. We hold stock, we deliver next day, we install for some. But really that kind of 100% availability was what we were striving for, what the whole industry was striving for. But as we move into AMP8 and the challenges around storm overflows and the real need to manage catchment, there's another there's an evolution to happen in our industry, and it moves past just availability. It's around where we can really drive catchment management, where we can really get data out of our network and out of our pumping stations to really give insights to those operators, to really be able to maintain those networks and essentially eliminate pollution, environmental pollution incidences. So that's really the kind of the evolution that Xylem's going on with the Concertor and in network pumping in general. And as far as Concertor is concerned, you know, everybody wants trouble-free pumping, right? That's what we're striving to get. But with that comes innovation, and hopefully you're going to hear from Simon later on about what that Concertor has brought to Yorkshire as far as that innovation. But that comes as a cost for us to develop, and it comes as a cost for Yorkshire to implement. But with that, with all innovation comes return on investment as well. So you're going to hear later on today about, you know, energy savings you get out of using this equipment, how much of a reduced investment there is, because really the whole life cost is significantly reduces. And really that kind of efficient asset management piece, you know, what Concertor does bring is kind of the removal of a need to select on every pumping station, and really provides a small amount of differing pumps to meet probably, well, we'll hear later, probably about 70% of what the needs are of the network. So that's really where Concertor's going. This is a case study which we thought we'd bring up. This is actually from 2017, okay, because Concertor's been around for nearly a decade now. This is really from 2017, and there were two sites in a water utility, which you can see the stats there. They got this 42k plus a year over two sites was the reduction in their per annum, was their reduction in their annual operational spend. So, you know, I think this was probably one of the first case studies we did in the UK, and it gave this really transformational kind of change to these sites, where they were going out to these, quite as you can see on the slide, they've gone out to these sites on numerous occasions, and now they just don't go and visit them anymore. So, you know, really, and Simon's going to show you some of the results from the Yorkshire operation.
Okay, I just want to take you back to the back end of AMP6, when we, as Yorkshire Water, got our final determination come through from Ofwat. And it was quite clear at that point that there were some new stretching targets that were introduced within the industry, and also within obviously Yorkshire Water. And looking at it from a wastewater perspective, we were looking at, you know, reduction in ISF and ESF, which are internal external sewer floods, pollution, reduction in reactive maintenance, you know, reduction in totex, etc. Lots and lots of different industry-wide challenges, which were, you know, it was a requirement for us to start to look after our assets far better, whereas in the past it was always around building new assets and you know, replacement of assets. This was more around, you know, Ofwat making a decision that we needed to start to look after our assets better and drive better performance by doing that. So let's move on to the next slide. So we looked at wider industry and looked at, you know, what effectively they were doing to sort of make that step change. And it was quite clear from us that we were looking at this maintenance maturity curve. We were at the bottom, right down at the bottom there, the fix it after it fails area, the reactive area, the regressive area. And often it wasn't fix it after it failed, often it was replace it after it's failed, which is a really expensive way of looking after your assets. So we needed to make the step change and start to make our way up this maintenance maturity curve, starting off looking at, you know, where we could fix the basics effectively, where we could make that initial leap, but then also hoping to migrate further up the maturity curve as we went through the AMP and also into AMP8. So when we pulled together all the transformation team to take a look at this, and it was a case of okay, what do we want success to look like? And we brought in some external consultants to help us in this. And it was a number of different initiatives and programs that we needed to pull together, things in, you know, in terms of people, data, IT, integrated planning, schedule, logistics, and customer experience, as well as what we formed as dynamic asset maintenance. So what is dynamic asset maintenance effectively? Well, dynamic asset maintenance is a group of different elements. So initially on the left-hand side, you'll see the dam standalone foundational part. This is more or less scaling up proof of concepts that we'd started towards the back end of AMP6 and into the early part of AMP7. But also looking further afield, looking at proactive asset maintenance, you know, making improvements to our asset records, you know, asset commissioning and decommissioning. Obviously, maintenance activities, looking at prioritisation, doing FANICA studies, determining where the critical nodes were and where we needed to do more active maintenance to help sustain our reliability of our assets. But also looking ahead to the future, to the far right-hand side, looking at predictive asset analytics. So this is looking at all the different data sets coming in from across the business, building up an holistic overview of what that looks and feels like, but also there's opportunities to see where asset performance is deteriorating so we can make some proactive interventions. Looking at the foundational programme then itself, there was one clear element within that programme called SPS operations, which effectively was just about short of half of the overall dam foundational programme. And it was quite clear that we needed to invest a lot of time and effort within this area to help reduce the corporate risk to the business, help to reduce the number of pollution incidents, customer contacts, etc. Okay, so what is SPS operations? So SPS operations takes us back, again, looking at the previous 5 years worth of data, and over our just short of 2,400 sewage pumping stations, we were actually undertaking 22,000 reactive visits per year, mainly to pumping stations where the assets themselves had become blocked and we needed to lift them out, clear them out, or repair or fix them or replace them in some occasions. Out of that 2,374 pumping stations, we actually identified that 40% were actually responsible for 90% of the reactive visits. And as you can probably imagine, these were quite troublesome, often causing issues out of hours. So we had to react as a business, quite a large amount of expenditure and quite a large impact in terms of health and safety. You know, we're working in, you know, poor lighting conditions, out of hours, in the middle of the road, doing traffic management, etc. on top. Obviously, quite a complex issue that we needed to deal with. And some of the sort of cyclical maintenance activities were very limited. They were more of a look and see rather than actually doing some serious maintenance activities and making the assets more resilient. So what do we want in our future state? So obviously we wanted more reliable, resilient assets, reduce the amount of pollution incidents, reduce the number of reactive visits, you know, cut down the driving, low light working at height, these health and safety risks that are, you know, quite evident once you get out onto these sites. Also looking at more planned activities. So if we could get more foresight of when things are starting to fail, we can then organise and plan to go and visit that site accordingly in proper daylight hours, you know, with the right resources, visiting to fix it right first time. One of the key players to get us to that point was a thing called pump reversal. So what is pump reversal? Effectively, when pumps get blocked, a quick and easy method to actually remove the blockage is to actually reverse the pump. So we looked at several different solutions that were available, but also tried to create and embed some of our own solutions. And eventually we got to the point where we understood the actual sites where we could make a difference, what the benefits were off the back of that. So that was obviously a leader into the investment to move forward, bring in some innovation to help us along the way. In terms of pump reversal, we ultimately settled on 4 different choices. Number 1, top of the list, the Flygt Concertor pump. Number 2, variable speed drive. Number 3, a Siemens Simicode. And number 4, a full control panel asset replacement. So in terms of the Concertor pump, the advantages there is obviously we have a new pump, a new asset in the ground to replace the existing pump. But the pump itself has got all the intelligence built into it. So it means that it can automatically detect when blockages start to form, and it can automatically carry out a job function to toggle the forward pump, reverse pump activity to clear the blockage. In terms of VSD, the latest VSD model that we had from our supplier had a pump cleaning function built into it. And again, it was a similar sort of principle in that the VSD itself detects when a blockage is starting to form, toggles the status of the pump forwards and backwards to ultimately shake free any debris. Similarly with the Siemens Simicode, which is an intelligent overload, very similar principle, slightly different configuration in the panel with forward and reverse contactors carrying out the reversing activity. And then ultimately the full control panel asset replacement, which was based upon variable speed drives as starters, as opposed to direct online or star delta starters. And again, you know, these were designed to effectively trigger off a pump cleaning exercise, so it removes the blockage itself. Now, in terms of looking at that particular hierarchy, obviously our preference was to replace the pump with the Concertor pump as our number 1, but we couldn't always achieve that on the particular sites where we were having issues. Primarily, the Concertor pump is limited to a certain kilowatt rating, so there were occasions where we had some sites where we had to deploy one of the other 3 solutions. Jason?
Morning, everybody. My name's Jason Robinson. I'm the account manager for Yorkshire Water for Xylem. I've been doing this role now for sort of 9 years. I'm working very closely with Simon and the dynamic maintenance team for the sort of past 3 years. When we first introduced the Flygt Concertor to Yorkshire Water, we'd done a trial on one of the sites, which had proved very successful. We then sort of introduced the Concertor as part of dynamic maintenance, and based on what Simon's been saying so far. But you know, what is a Concertor really? So we're looking at very similar to the submersible wastewater pumps that probably most people know. But it's got a permanent magnet motor in there, which is equivalent to IE4 efficiency. One of the big things with the Concertor is the rationalisation of the product. So compared with a lot of Xylem products, a lot of competitor products, we're looking at probably 3 models will cover between 60 and 70 product ranges. And I'll touch on why that is in a moment. We've standardised on hard iron impeller insert rings down in the sort of bottom corner as you're looking at it. The adaptive impeller, which was introduced into the smaller fly pumps many years ago, has the ability to hydraulically move if it senses it's getting a blockage in there to start off with. And then, as Simon said, with the Concertor, if it detects it's getting a blockage that the adaptive impeller can't move clear, the pump will actually reverse at different speeds and go at different forwards and backwards to try and clear the solid. And then within the Concertor, you've got the integrated control system in the top, so a variable speed drive. Now within that drive, you've got the ability to alter the performance of the pump. We've also got the ability to look at how you want that pump to control. So if you add in a gateway to the actual unit, you can bring in enhanced functions like pipe cleaning, sump cleaning, energy minimisation, and optimization. Probably one of the main differences between the Flygt Concertor and our own product and many other products is the way that we actually control the performance of the unit. So if you take a typical product, you might be looking at one size. You could have eight or 12 different impellers, 4 or 5 different motors, and you can trim those impellers then to suit the actual duty. The way we do it with Concertor is we actually have what we call a performance envelope or performance field. And using the variable speed drive, we can adapt the pump both in commissioning. If at a stage you find that you need to increase or reduce performance to adapt the process, we can change the performance there. And essentially, we've got three different impeller sizes, or sorry, discharge sizes, which are 80, 100 millimetre, and 150 millimetre. And we've got 4 motor sizes, so 2.2 up to 7.3. The 150 size is only available up to 5.5 kilowatt, and that's really a commercial decision to bring in those motors. What you could actually do if you really wanted to sort of rationalise the product you've got in there, rationalise the stock that you're having to hold to support it, you could actually get away with just going for the larger motor size on each of those product models. You saw it.
Okay. So basically, we decided to invest in obviously pump reversal, Concertor being the primary preference. But which sites effectively do we need to go out and actually make a big game changer? So out of the 2,300 plus sites, we identified 888 sites, which were the ones that were causing us the most headache. Predominantly, those sites were 15 kilowatt or less with small outlet pipe sizes, so 80, 100, 150 mil. Repeated offenders that kept continuously causing us headaches and blockages. So looking back at the specific criteria, anything less than 15 kilowatt was obviously identified as an auto pump reversal solution, but we identified as well that anything less than 7.5 kilowatt would primarily be the Concertor solution. We used the previous 5 years reactive visits, prioritised from a high to low, and also to other things such as pollution risks, so proximity to water course, previous history of pollutions, previous history of localised flooding, the asset age, so how old were the previous pumps. Catchment adoption was another one. So we wanted to make sure that you didn't have a mixture of different types of pumps, etc., out in a specific caption, and also looking at whether the site had already got existing variable speed drives or soft starters. So once we sort of filtered down that list, we actually had a prioritised list from high to low, where we could then target the deployment of the new pump reversal technology.
So how we looked at this when we worked with the Yorkshire Water from the start was really 4 steps. Yorkshire Water primarily sort of said that to get the sort of biggest bang for the buck, they didn't want any sort of unnecessary site visits, so there was a lot of desktop studies that were completed. So as Simon said earlier on, looking at the initial data in stage 1, we looked at 2,500 pump stations. We looked at the product ranges below 10 kilowatt, below 150 millimetre discharge, and quickly got down to about 500 stations that could be adopted, or sort of 20% of those stations. Stage 2 then was, and many of those sites as well might have been originally in the 1970s, so some of the data was sort of sketchy, some of it was sort of obsolete and whatever else. But so we went from stage 1 to stage 2, which was then looking at the data that we had. So we looked at sales data that would supply to Yorkshire Water. Yorkshire Water provided us further information on the pump stations that they had, which was sort of later information. We then went to stage 3, which was really providing a quotation to Yorkshire Water. Subsequently then followed by an order, and then would go and do a site survey. If at that stage, and this was really working as a team with Yorkshire Water, if at stage 3 we got to the stage where the product wasn't what we were expecting, there might be additional equipment required on site, such as non-return valves or whatever. We had a final stage, which was with Yorkshire Water agreeing the change in the scope of the order, so then we could sort of get on site and do the installation as quickly as possible.
In terms of the solution, obviously I mentioned we have 4 solutions, obviously Flygt Concertor being the preference, and then VXD, Simico and full control panel asset replacement. And the way that we selected the solution per site was actually through a very simple basic flowchart. So we asked them fairly basic questions throughout that flowchart, and that ultimately popped out the preferred option to go and deploy. One of the reasons why we wanted to make Concertor the preference, flexibility. The same duty can be covered by multiple different models. The ease of upgrade, effectively, you're pulling a pump out, you're putting a replacement pump. So in terms of that delivery model, it was very much an asset replacement type of program of work that we wanted to deliver. We wanted to try and reduce the number of overheads and design requirements, etc. Cost and availability. So this product, as you said, had been more or less on the market for the best part of 10 years. The price and the availability of the product was very attractive to us. It also, in terms of if the technology didn't work, it was easy for us to revert back to a previous type of pump, which again gave us more flexibility, and also future opportunities in terms of how we could bring in further optimization to help us even further down the line. One of the other benefits that's come out of the back end is the actual energy efficiencies that we're starting to see coming out of this product as well. So it's making a key difference in the energy that we're using as a business. So the methods used, obviously, as Jason's mentioned, there are effectively 4 power ranges for the Concertor and 3 different outlet sizes to select from. We knew that our asset records weren't necessarily in the best condition, so couldn't be relied upon. So the 4-stage process that Jason mentioned earlier, it was quite key to us gaining that true understanding of what we needed to do in terms of how we selected the pumps. And also, not all the pumps we were looking to replace were Flygt pumps. There were other competitor pumps as well, and we needed to consider how we would go about changing those. And thankfully, there were specific adapter flanges available, either to get straight off a shelf or could be manufactured to make the Concertor pump fit onto the existing pipework. In terms of the actual selection of the pump and the set power settings, there was actually a lookup table that had been provided by Xylem, which was key. It was quick and simple to understand, and it meant we could place orders in batches and get work underway pretty rapidly. So just continuing on the delivery model, again, to make it flexible, we decided to deliver the program in small batches, so batches of 10, and the quotations would be per site. So we would receive a batch of 10 quotations, convert those into purchase orders. But then obviously it was around the collaboration between Yorkshire Water operations team and Xylem's program management team to then look at how we could get that into a mini program of work and get out onto the sites accordingly. If it was later deemed that the Concertor wasn't the right way to go, we could also bring that back into the other auto reversal program and look at a different solution if need be. The Xylem technical team, they were brought on board because of their expertise. Basically, they had all the knowledge and understanding. Obviously, done many pumping stations over the years, and they brought a real fresh outlook into the approach that we were looking at, and also helped us in terms of looking at our overall strategic stock through our centralised logistics centre. So it meant that obviously we could sustain what we had delivered. In terms of time frame, So effectively, we started this journey really early in AMP7, but we never got the momentum until round about the sort of early part of 2022. So we looked at effectively the number of assets and the number of sites we wanted to put into the Concertor programme, and that was 1,260 pumps across 630 sites. And we looked at, obviously, the time frame for that was between when we first installed the first pumps in February 22, all the way through to the end of the AMP period, which is March 2025. And looking at that, that was effectively a run rate of greater than 34 pumps to be replaced per month. So this was a rapid deployment activity. To get ahead of the game, obviously, we needed to make sure that the equipment was available to us. So that product lead time was minimised as much as possible. And also this direct relationship between the operations team and Xylem helped to build up the sort of trust between ourselves and Xylem, where we could then just basically let Xylem onto the sites as quick as possible, get the assets swapped out and upgraded, and obviously start to gain the benefits from that as quick as possible. In terms of the project management, there was almost a daily collaboration between our own Yorkshire Water project management team and Xylem's. And another part that sort of popped out was, well, what do we do with the old assets? Because some of these assets aren't necessarily that old. And we felt it was quite key that we wanted to try and retain some of the best of those assets as potential strategic stock for emergencies. So again, we looked at potentially how we could deal with that. So what could we do with the old pumps? Again, through a small sort of process flow chart, we looked at the pumps, we looked at the age of the pumps, condition of the pumps. Xylem Workshop did a quick assessment, to determine, what condition the pumps were in. Often giving them a quick clean up as well, measuring the cable lengths, and then marking them up ready for retaining within our localised containers. So we have 3 specific locations across the Yorkshire area where we actually distributed the retained pumps. Not all pumps were retained, some were ultimately scrapped, but obviously the best ones that were still in decent condition were retained, again, for emergency uses within the business. Another element that we called basically supplementary enabling work was, obviously, we've got such a vast and varied site infrastructure across Yorkshire. A lot of the pumping stations that we have actually been adopted and weren't actually built purposefully by Yorkshire Water. They were built by third-party developers. And we soon started to come across some issues in terms of the site infrastructure. Non-return valves that were either blocked or passing, guide rails that were starting to rust or even broken, benchmarking as well. So on some sites we didn't have benchmarking, on others the benchmarking was too tight for the Concertor pump, so we had to make some adaptations. Inlet flow diversions, all sorts of things like health and safety hazards as well. All of these needed to be overcome to enable the success of the work that we were trying to undertake. And it was just making those little decisions rapidly, making changes to the purchase orders to enable Xylem to continue their work and obviously provide the benefits as well. Okay, so how did we track? So there were several different things. Obviously, there was collaboration on almost a daily basis in terms of meeting up with Xylem, checking progress, going through the actions list, making sure that we got all the support needed from our operations team and obviously wider Yorkshire Water teams as well in terms of Yorkshire Water Craft. We had a dedicated tracking sheet so we could monitor within that tracking sheet all the different status of each of the different pumping stations that we got in the programme. We had a programme plan that we regularly updated, plus a RAG action list, so red, amber, green action list, so that we could work our way through, pick out the highest priority risks, start to deal with those first, but also make sure that we continue to cycle back round to the rest of the action list. So how did that look and feel on the ground? So basically, I'm just going to go through a little bit of a photo deck. And this is just looking at some of the installation that went on a typical wet well installation. So here you can see, as I put the photos through, you know, we had to isolate the flows, we had to put standby tankers and jetties in place. In some instances, confined space entries, working at a height, hot works. All of these were key elements that needed to be properly managed from a health and safety perspective, as well as from a work organised, planned activity as well. Obviously, several different obstacles to overcome. Not all of these were relevant for every site, but obviously it was on the occasions where we needed to do so, some more in-depth activities and go actually into the wet well, where we needed to make sure that we organised and carried out the activities safely. But it wasn't just wet well installations. We also undertook work on dry well installations as well. So on a couple of occasions, we had some shaft-driven pumps that had caused us no end of issues. And we took the strategic decision to basically try and eliminate that issue and actually convert the site across into a dry well installation with concertors. And again, this was, you know, one of the things that was more planned out, a 3-day activity as opposed to a single-day activity. Again, things such as confined spaces, working at heights, hot work, scaffolding, pipework modifications, etc. All to take that step change from a shaft-driven pump into a concertor pump, which again would give us the advantages for the auto reversal activity. Okay, reporting. So obviously it's key when we are sort of delivering a huge program of work and activities such as this. Our wider stakeholders and leadership team were regularly kept up to date with our reporting system. So our project manager brought together a Power BI dashboard, which identified key activities, but also the progress that we were making. And, you know, we were getting to the point mid-program where we were deploying in real terms 55, 56 pumps per month, so quite a significant run rate. And we needed to make sure that we sort of shared that understanding with the wider stakeholders, so that, you know, the operations team knew when we were coming to their sites, but also, you know, when we successfully completed the work, so they can then track the benefits off the back of that. And we were quite keen to celebrate our successes as we went along the way. So we set specific milestones as we went along. One in particular, the total of 500 pumps was a key milestone to get to. And it was good to sort of share that with the wider business and, you know, make people aware of all the good and, you know, timely effort that we'd put in. You know, it was great for us to have some recognition for that effort as well. And it helped us in the longer term, you know, to turn around some of the culture, I guess, within the business, which we often faced into, you know, and had some pushback on, if you like, over the time that we were deploying the equipment. Another key element was training. So traditionally, electricians would deal with pumping systems, so they'd check the pumps for, you know, insulation, resistance testing, etc., determine whether the pump was still operational or not. That was slightly different when it came to the concertor pumps, because you can't actually do some insulation resistance tests on concertor pumps. So we had to go through a training exercise with the electricians to bring them up to speed into how you could basically plug into the pump itself and interrogate the pump and use the pump as a fault finding tool, in essence. But it was also good for us to sort of demonstrate what the pump actually did. So there's a few links on this presentation, which takes you to YouTube for a few demonstration videos, which are really, really good. I would recommend that you watch them. It really does highlight the difference between a conventional pump and how the Concertor pump actually deals with rags that enter the pump. Very, very intuitive as well. In addition, we also created our own in-house videos. So in terms of our IT technology, our field teams use a slightly different device called a Toughbook. And we basically created our own internal training videos using the Toughbook as the device, and also obviously the additional equipment, the intercom device called the PCM device, and took them through how they would go about connecting up to the pump, how they would go into the software, do the interrogation, and ultimately how they could produce a service report out the back of that as well, which could potentially be utilised by Xylem to help us determine root cause. But also it meant that we got a configuration record as well as to how the pump was originally installed and commissioned. I mentioned insulation resistance. Can't do that on a Concertor pump. Basically, it's a variable speed drive in the top of the pump. So you wouldn't actually be carrying out an insulation resistant test on the motor itself. You would actually be potentially damaging the variable speed drive. So it was quite key that we put warning labels onto the starter panels to make the electricians aware of this, as well as backing it up with this particular training activity. Anything you want to add, Jason?
No, I think you could most of the things. I think the main thing was in touching on the speed of deployment that we'd had with 55 pump stations being converted at a time. It was just really familiarisation with the Yorkshire Water craft engineers, and that's why this training was was key. And what we'd done is, from the outset of the programme, we'd done training, but then we revisited that just to try and bring people up to speed with the product, with the familiarisation, and let them know the training packages that were available to them.
Yes. In terms of the continued support, so we actually embedded a reliability period into the programme. So this was a short period, 3 months, whereby once we'd installed the equipment, if anything occurred within that 3-month period, which had an effect on the site, then Xylem would return, carry out a root cause investigation to determine what potentially has caused that issue. In most of the cases, it was something that was not essentially contributed by the Concertor pumps themselves. It was often a site infrastructure issue, so maybe an NRV that would start to pass or become blocked, that ultimately led to the reliability issue. But ultimately, that additional support that was provided by Xylem was quite key to get us over this little hump that we needed to throughout the programme. It also gave our craft team some additional support as well, which meant that they get more and more confidence as they went through the programme. There's also a warranty, so I don't know whether you want to just explain the warranty, Jason?
Yeah, so the warranty with the product was within the framework. We have an agreed warranty period on the actual product. That will differ depending on frameworks and customers, but essentially we had the 3-month reliability warranty, and then that's backed up by the warranty on the overall product.
And there was also other people. So we have other teams within the business as well that were looking at the information and the data, looking at the pump performance, and we had some issues on some sites where we had to go back and do a little bit more work. Typically, where we had issues that were site infrastructure issues, so where an inlet was actually falling directly onto the pump and causing air entrainment. Ultimately, we overcame that by installing a baffle plate to make sure that no longer was causing us issues. There was a pollution task force and a performance and assurance team looking at PFF as well, all of which helped to continue that support element within the business. and helped us to get to the point where we were fully in acceptance of the benefits that were being provided. So we're now at the stage where effectively we are heading towards the back end of AMP7, and we're going through the transition where we're effectively handing over as a program team into business as usual. So lots of different things that we're talking to the business about. We're talking about that reliability period, the warranty, updating our asset records. Obviously, one of the other things that came out of this is our asset records were ultimately pretty poor, and we needed to get better at that. Training, communication and engagement, all the usual stuff. Strategic stock is another one which is quite key, making sure that we've got spare concertors sat in our logistics centre ready to go, but also a renewed framework agreement. So as I mentioned right at the very beginning, this agreement with Xylem is a continuation basically of what we had in place before, and it means that we can continue to have that sustained success as a partnership. So what does that mean overall in terms of our return on investment? So the investment was planned to be returned within AMP, so within AMP7, obviously, which finishes at the end of March. We actually start the programme in February 22, so we've actually had a 37-month programme deploying all this equipment. Our current return on investment, which was calculated by our finance business partners, is showing a return of 140%, which is fantastic, really. It really is. What's it mean in terms of the reactive visits? So I mentioned over 20,000 reactive visits a year, and we've actually seen on 96% of the sites, we've seen a reduction in that. And overall, a 51% reduction in reactive visits across all the sites where we've deployed the concertors. So an absolutely massive difference that particular program has made to the business. But also energy. A lot of these pumps are only small, 2.2 kilowatt, 4 kilowatt, 5.5 and 7.3. They're not the biggest assets out there. But to actually make a validated 13% energy reduction across that estate that we've deployed results in around a 45k per month saving to us as a business, which is a huge step forward. But it doesn't stop there, because obviously the benefits will also roll across into AMP8 and beyond. Just wanted to pop this slide in just to give you an understanding from a statistical point of view. I appreciate it looks a very busy slide, but if you look in the graph itself, you'll see that actually before we deployed the concertors, the blue part of the graph was quite significant. But then if you look at the red part, that is post-concertor. And this is all based on mean averages of reactive visits per month. And you can actually see it's made a significant step change to the business. So whereas we were getting repeated instances of blockages causing us these issues and headaches, we've made a step change now, and we've more or less eliminated the majority of them. There are a few outliers, so you'll see within the oval shapes, there's a few one or two little dots in there still residual. And in general, these again are down to site infrastructure issues. So we're looping back round and going back to these sites to determine what that root cause is and what we can do about that as well. On to the benefits. So the benefits themselves were effectively in different levels. So the top benefits, as outlined in our PDD, which is effectively our business case, reduction, elimination of pollution events, reduction in planned work, reduction in reactive call-outs, reduction in energy consumption. So as I mentioned previously, we've made some leaps and bounds in terms of seeing those benefits land from the deployment of concertors. But there's other benefits, and there's other levels of benefits. So, other direct benefits, improved network visibility. We can see how our assets are performing. Again, reduction in reactive capital. In a lot of cases, when these pumps blocked, they often burnt out, so we had to basically buy a new pump to replace the asset. Better utilisation of our resources as well. So it meant that we could basically send the right people to the job to fix the right pump at the right first time. And I mentioned some of the obstacles we've overcome as well. So we've improved some of the site infrastructure. You know, we've replaced and repaired ducts, rectification in panel faults, etc. as well, swapping out overload units, contactors, etc. And we've also had some non-tangible benefits. Effectively, we have made a difference. We've made a reduction in customer complaints. We've enhanced the company reputation because we're no longer spilling, causing floods, causing pollution, and associated health and safety as well, which is quite key. We're not sending people out at 2 o'clock in the morning with a torch trying to swap out an asset that has failed in the middle of the night. Okay, well, that's it for me. I think over to Leah.
Hi everyone, welcome back. So that'll be the end of the break, and now we are going to go into some learning and challenges, which will be a kind of panel style discussion from the team, followed by 10 minutes of what's next for the collaboration. So welcome back.
Okay. Yeah, I guess probably the one at the top of the list is probably the biggest one that we've had within the business, and it's changing the culture from that reactive, regressive approach within the business where we're constantly we're in firefighter mode basically, always on the alert, reacting to alarms and alerts and blockages, etc. as they come into our central control room and then get passed out to our operations and craft team. And that change of culture from now relying on the equipment to make the decision, the equipment to look after itself, and utilising that information and data and passing that back to our operations and craft team for them to gain that level of trust effectively. That's what the big culture shift has been, that's been driven by this piece of work. It's certainly been a hard-fought battle, I think. I think you'd agree, Jason. It's taken a lot of time and effort, continuous sort of communication and engagement with the wider business to help us sort of embed, that culture change and sort of lay down the markers to say, this is the evidence that we've had, initially from our proof of concept, from the trial that we undertook at Burnsville Car Park way back in the sort of early part of AMP7, through our continued iteration of deployment, basically confirming the numbers, the return on the investment, the benefits that we've seen off the back of this, and obviously taking that across to the business and explaining, even if this is not necessarily a silver bullet, it's not a fix-all asset, you may still have issues, but in general I think it's fair to say that this has resolved 90% of the blockages that we've had as an issue across our smaller submersible pumping fleet.
Yeah. And do you think you would have done anything different, knowing now what you know?
Yeah, I think I mean, off the back of the success that we've had, I would suggest that if we'd have known about this sooner, as you mentioned, the program's been about for 10 years. And it falls back to that knowledge sharing, where as an industry we were very siloed. People were doing their own thing. Now we're starting to see that general communication going out to the wider industry and suppliers. Even you guys are learning things from the wider industry as well, and bringing different opportunities to us as a business that we can then start to embark on and make some real inroads in how we invest our money smarter to gain the advantages that we need.
I think it's probably right, because how we invest now in Concertor is a lot to do with the feedback we get from customers of what we're doing at this stage. So that's good. Yeah. And just what about the transformation piece? Because you've obviously had to go through a massive change process with your
Absolutely,
with your Yorkshire Water employees, and that sometimes the hardest part, isn't it? So
It is. I mean, we actually we stood up a dedicated transformation team, of which I was one of the members of, in terms of the dam programme managing. And as part of that exercise, we brought in a business change team as well.
Okay.
And they outlined it to us right in the early stages that to embed and ensure success, you need to bring the people change element along at the same pace as you were going in terms of deploying equipment. So there was a lot of work that was undertaken, doing business impact assessments, looking at how this would affect the business going forward and what the as-is state was and what the to-be state would be. And effectively, the final 30% of success is embedding that within the people side of the business. And ultimately, the business change team has helped us to facilitate that, really. So very useful.
okay. And what other benefits did you get from the process?
Yeah, I think strange, isn't it? Because as a water industry company, we're not built for delivering change to a certain extent. We do apply a lot of change, but we don't necessarily embed it and sustain it as much as what we should have done in the past. And that's made just as much of a step change to us as a business to have this embedded business change unit helping to drive that cultural change overall. And the benefits from that is we've now got people who are fully bought in. We've got people that are actively now starting to look at the pumps. They will go and plug the PCM device in. They'll go and upload a service report. They'll have a look and see what that information is telling them as to what the pump performance has been like over the past 12 months, 24 months, for however long it's been in. So again, it's helping them understand the asset health and performance, but also giving them another fault finding tool as well that they can utilise.
Okay.
Like I say, I think their engagement is absolutely key in making it work as well.
Yeah, yes.
Okay. And what about the enabling works then?
The enabling work in particular, we knew obviously we adopt a lot of assets from the wider development activity that goes off, where people build new housing estates, etc. But there was a lot of newly adopted assets that were in pretty poor condition, and we didn't have a fix-all. It was a case of what can we do to bring them into a reasonable condition. First and foremost, can we stop the blockages through deployment of Concertor or the other water reversal solutions? And certainly, one of the key areas where we found that we could identify other failure modes through Concertor. So, the actual Concertor itself has got a lot of different alarms built into it, which gives a lot of status information. One of them was a DC bus over voltage. And we found that actually the majority of the time, the trigger for that is a failed non-return valve on the other pump. We've never understood that before. We've definitely never had visibility of that as a failure mode before. So it was really useful for us to say, okay, we've got a DC bus over voltage. Let's start looking at the NRV on the other pump and see if that's okay or not. More often than not, we found that actually the NRV had failed on the other pump, which meant that the pump was circulating back through the other pump effectively. So yeah, really useful to have that opportunity to take those different types of failure modes.
Okay, good.
I think as well, Simon, on that, historically, we're talking about product sizes where if the NRV had failed, you'd see it as being a pump failure. The pump got replaced, the NRV never actually got changed.
Yeah, absolutely. And other areas of improvement, obviously, we've replaced some collapsed ducting. We've done some health and safety issues, resolved existing site infrastructure issues, putting baffle plates in, so the inlet flows directed away from the pumps. Pretty basic, but it makes a difference. It stops you from getting air entrainment in the pump and airlocks, which are, another failure mode that we've often had difficulty dealing with. So, yes, some of that enabling work has just helped us to get over the hump and just, you know, drive some real benefits out of the deployment of the concertors.
Good. And what do you mean by the low hanging fruit versus complicated sites?
Yeah, so there are obviously specific sites which may have the wet well in the middle of a main road. So, you know, to actually gain access to the wet well in the first place means we have to introduce traffic management. Obviously, we have to get in touch with the local councils for permits and that kind of thing. You know, in some instances, we wouldn't have any sort of lifting equipment on those particular assets because they're in the middle of the road. So we'd have to hire, you know, a hire or whatever, some sort of asset to be able to withdraw the pump out of there. So that, you know, we tried to make the program as flexible as we could, whereby we could basically hit the low hanging fruit sites, so the ones that we felt were easy, quick hits, but then planning the ones that are more complex. So things like sites where we might need to do confined space entry, working at high traffic management type of activity in a planned manner. So it gave us the opportunity to say, okay, you know, out of this batch of 10, we've got 8 sites we can hit really quick. These 2 sites are going to be problematic. Let's make sure we map out and plan how we're going to do that work, so that when we do land on site, we've got all the equipment lined up, we've got all the resources lined up. So it means that the site activities then deliver successfully.
I think as well on the obtaining permits, when we first started the programme, obviously you were looking at 34, 35 sites to be converted each month. One of the issues that you have is with the permit writers, there's only a finite number of permit writers in there. The other one would be getting access to sites. So one of the step changes we made quite early doors was all of our engineers are electrically authorised by Yorkshire Water. We had access to the sites, or we had the keys to the sites. We could go on and unlock the sites and do the work ourselves. We'd let the Yorkshire Water control room know that we're on site doing the work. We'd let the control room know when we're off site and finish the work. So all of that allowed the sort of speed of deployment to improve as well.
So really collaborative.
Yeah, absolutely. Yeah.
And you should probably mention something around this product material shortfall during COVID. We shouldn't miss that one out.
Yeah, yeah. One of the downfalls from COVID, you know, when it came to electronic type equipment, of which there is quite a large amount of electronic equipment within the VSD part of the pump itself. Not always readily available. So Xylem did a fantastic job of sourcing alternative components and component parts to obviously introduce into the pump. So it meant that we'd always got a reasonable amount of stock ready to go, sat on the shelf, hit the sites and away we go, sort of thing. So it's quite key to make sure that we got that sort of continued deployment.
And do you think it held up your programme, or?
I think in the early stages, it may have held up, you know, for the first 2 or 3 weeks. But then once we started, you know, we said we wanted to do it in batches. And once we got into that methodology of releasing batches of 10 sites at a time, obviously, initially, orders were placed with your colleagues in Sweden, and obviously shipped across. But then ultimately, once the sort of COVID issues and the equipment issues have been resolved, then it sort of turned around even further, where you were actually ordering product beforehand. It was already in the UK, so basically all you were doing was relocating that product into Yorkshire, so we could basically deploy it. So it worked really well. Yeah,
we do hold stock in the UK locally now for this kind of just a kind of on a kind of Kanban system for these type of projects, which helps them. I have one final question. Okay, this is unfair because you don't know it's coming, but I'm really interested in whether the lessons learned around stakeholder engagement within Yorkshire, you know, getting innovation from the supply chain into water companies is sometimes difficult, right?
Yes.
And I wonder if there's any lessons learned around the kind of stakeholder management piece.
I think one key element is knowing who the stakeholders are in the first instance, and also when there's change in the business, who are replacing those key stakeholders and who needs to be kept up to date, because we have such a variety of change across the business over the past 3 or 4 years. where we initially engaged with a group of resources within and staff within the business, they've often moved role as we've gone through the programme. So keeping track of who to engage with, who to keep regularly updating has often been quite difficult, I must admit. But the business change team as well have sort of helped us along in that regard. So they've obviously got that understanding with our HR teams and the people leaders. Who's moving on and who's moving around into a different role. So who do we need to keep engaged and update.
Good, thank you. It's good to reflect on these things for other projects we will work on and for other people who will listen to us.
I think one of the other things that came from that were when you start having successes in certain areas, you then get other stakeholders coming in wanting some of that to be rolled into theirs. And I'm thinking like pass forward flow. There's stakeholders there that weren't really considered as part of dynamic maintenance. But
yeah, absolutely. You're right, and obviously off the back of the success that we've had, we're already looking at wider parts of the business as well. We mentioned the sewage sort of treatment side of the business, which have got quite a lot of process assets on. Looking at those particular assets, where they're having issues on those particular sites in terms of reactive visits, and whether there's a value in investing in deploying water reversal on those particular assets and processes as well.
Brilliant. Okay, I'll leave you to talk about the future.
thank you very much, Andrew.
Sorry.
No, you're absolutely fine.
Just having a bit of so in terms of future investment, obviously we are rapidly heading into the closeout of AMP8, and we've already started to work our way through the final determination that came through recently, just before Christmas, and look to see what that actually means to us as a business, and where we can continue to invest in these innovative type equipment and devices. One thing in particular that we were keen on was looking at the data infrastructure layer, which is a platform that's available through Xylem called Avensa. We did some initial trials, so we went to a site called St Paul's Parade, and we deployed what was then the DP format of the Concertor Avensa data infrastructure layer, just to see what that could tell us. And it was really useful that you could start to sort of visualize the additional sort of failure modes that we could detect, the additional data that we could pull out from that system, which is more than we've had before. In the past, we've had a very limited telemetry system, which has a small amount of status data that you can pull across, and obviously a limited number of alarms. But with this Avensa platform, it gave us much wider visibility, obviously remote visibility as well, so we can see what the true performance of the concertors are. It also has obviously some other benefits associated with it in terms of that sort of future sort of state that we wanted to get to for optimizing our assets. So at the moment we're currently looking at the DP format, but there are other formats such as XPC as well, which I'm sure Jason can go into in more detail, which offers additional optimization benefits. So again, what we want to try and do is double back round on the pumping stations that we've deployed Concertor to date, revisit those pumping stations and look to see which of those pumping stations we can deploy the Avensa platform on. Again, just to make that step change in terms of the maintenance maturity curve.
So just going back to what Simon's been talking with Avensa and the sort of really the wastewater pumping journey that we've been on as Xylem, and sort of helping Yorkshire Water sort of develop their business as well. So for about 100 years now, we've been doing wastewater pumping. So we started off with the wastewater pumping. We've then gone into sort of clog-free pumping. And really now what we're trying to do is sort of optimize the actual pumping process, the pumping system that the customer has. So by touching on the gateways that we can bring into, as I said earlier on, you can add in different functionalities to the product, like pipe cleaning, like sump cleaning, like energy optimization. But then as we go into a Venture, we're really trying to enhance the visibility of the actual assets to the customer. Where we're looking for a Venture is really how we help the customer make informed decisions on their asset. You know, this is their asset that they're looking at. It's not really our asset. But so a majority of customers now might have a limited insight. So they're doing frequent site visits. They're doing planned maintenance. It's on a time base. They might not be doing first fix failures, which they're obviously trying to do. And there's a lack of priority, so you know they're just doing a round robin of what sites they're looking at. What we're trying to do with the Venture is give you sort of data-led, give the customer data-led decisions. So, i.e., what we're looking at is trying to provide as much information on the actual asset as we can, allowing the customer to make a decision when they're going to visit site. Actually, if they need to make a site visit, if it allows them to go somewhere else. And I think importantly, from a maintenance background, it's are you able to focus your time and your resources to actually go and fix something else that's broken rather than looking at a pump station? Yeah, it's also trying to enhance the first fix failures. So it's providing that insight to the craft to say what site do I need to go to? What tools do I need to go to? With what parts do I need to go to? So that all comes from the data-led decisions that Venture can bring. And then really we're looking at the data insights. So it's a case of with the data insights, we can actually look at saying how is your pump station performing? Are you optimizing it? Is there any areas for improvement for that? So what does the Venture offer look like? So we're starting with asset visibility. So first of all, what we want to try is improve the asset availability, the asset visibility to the customer. And as Simon touched on earlier on, a lot of these pump stations, they might be inherited from developers. It might be in local councils, local authorities. So we're trying to provide as much information on a Venture as to physically what's installed in the ground. On the actual visibility, what you can do is you can then link into things like operation and maintenance manuals to products. As Simon said, every time we do an installation, we give them a commissioning sheet for the product that tells you what power it's set at. You can add all that into a Venture. So basically, you're looking at physically what products have I got, what information do I need to support it. So the insights I touched on earlier on, it's really looking at anomalies in the detection. So is one pump running more often than the other pump? Is one pump starting more often than the other pump? You know, so we can look at saying, is there something wrong with the control philosophy? Is there something with the level controls? And then finally, we're looking at remote inspection. So there are a number of pump stations out there that might suffer from frequent blockages. They might be getting more water going into the pump station than anticipated. It might be surface water that's going into a sewage pumping station. So with remote inspection, we can add cameras, we can add sort of level control in there, and it gives the customer the opportunity to see actually what's going on the pump station. There could be 50, there could be 100 miles away, but they can actually see what's going on in any problematic pump stations. And then really there's, so when you look at the events here, it gives you that visibility. So you can have it as a web-enabled tool, you can have it on a PC, you can also put it on mobile devices such as Toughbooks, such as iPads and iPhones. And you can tailor this to exactly as you want it for your assets. So you can look at how many pumps are in there, which pumps are operating. You can add in geographic maps of where the sites are. You can also look at weather and participation. So, for instance, if a pump station is operating more often than you expect it to be, it might be something to do with the weather conditions. And as I said earlier on, you can add on notes and documents specifically for that asset.
Okay, so just coming back to existing installs. So the intention is to look and invest into a Venture for all the pumping stations that we've deployed on today. but also future installs. So we're well aware that there's a new product that's being developed, a larger concertor pump, which can obviously mean that we can expand our range across the business, and also take into account that we've got still some sewage pumping station assets that ought to really be considered as part of a future deployment program. So I believe we've got somewhere in the region of around 1,000 further assets, which would be suitable for the small concertor, and around about 400 assets for the larger concertor, all of which would obviously we consider to deploy the Aventa system on top of the deployment of the pumps as well, just purely to take advantage of this fantastic innovation opportunity and bring more foresight into the business, get that data into the right platform so people can make informed decisions, send out the right resources at the right times to go and, you know, deal with any sort of failures, but also help us to sort of sustain what we've already delivered throughout this current programme in AMP7.
And then really, Simon touched up on there, at the moment we've been looking at what we call the Flygt or the Concertor 6020 model, which is up to 7.3 kilowatts. Launched this year, and in the EX variant towards the end of the year, we're going to have the larger sizes up to 13.5 kilowatts. Then we're looking at the sort of standardisation and rationalisation. So it's a case of, you know, if we look at the 1,000 assets out there, how many of those can we sort of standardise? What rationalisation of stock can we do? And again, this is a journey of continuous development. So this isn't a case of sort of just developing one product range and then sort of stopping there. It's a case of we've now developed the larger product range, and then in the future we're looking at larger products on the Concertor range in addition to what we have at the moment. And then, as I touched on earlier, on the remote inspection possibilities.
Thank you, everyone. So we are now going to go into our Q&A session. And if you want to join us again, I'm just going to stop sharing so that you can see the lovely team a little bit better. Okay. So, first question from Charlotte, I think for Simon. How much of Yorkshire Water's SPS asset base can realistically be replaced with concertor pumps, and how many are left to find alternative solutions?
Yeah, pretty much as I mentioned. So this particular programme is looking at 1,260 of the smaller concertor pumps. We've looked at the sort of wider asset base within the sewage pumping stations and identified potentially a further 1,000 on the SPS assets. We've not started looking at the wider sewage treatment assets yet, but we believe, you know, you're probably going to be looking at similar sort of numbers in terms of small assets on sewage treatment works. In terms of the larger concertor, at the moment we've identified around about 400 sites. And again, if we start to take account of the wider sewage treatment sites, you know, potentially that could go up to 800. So quite a significant amount, really. You're probably overall, in terms of our pumping assets, obviously we do have some really big assets which wouldn't fall in the concertor, but you know, you'd probably be looking, I would suggest, around about 40% of our assets could potentially be converted across into concertor.
That's great, and it's kind of increasing overall efficiency of the pumping stations altogether. Then brilliant, amazing, thank you. Okay, next question also for you, Simon, is, as the Concertor have on board VSDs, were the existing VSDs installed on the SPS for controlling old pumps removed and decommissioned?
So any site that had got an existing variable speed drive, we didn't deploy concertors on. We took the decision that would actually either utilise the existing variable speed drive if it had the capability, or install a replacement variable speed drive and carry out the pump cleaning functionality through the drive itself, as opposed to putting a new pump in. And again, we've seen advantages of that. Obviously, there's a significant cost difference, but you know, ultimately, as mentioned previously, it was all about getting into that position where we could overcome these repeated instances where pumps were getting blocked. And we adapted quite a bit as we went along the process and tried to make sure that we selected the best solution for each individual site.
Fabulous, thank you. Okay, so there is one more question for you, but I'll mix it up a bit and go to Jason next. So question from John for Jason is, how do you distinguish between the benefits of well cleaning / benching repair / replacement NRV etc at the time of the installation of the concertor? Do you have data over long periods, and have you introduced additional maintenance programs such as well cleaning?
Okay, so I'll answer that in a few ways then. So when we're looking at benching, as we've gone round a number of the pump stations that we've converted to Concertor, we've identified that the bottom of the sumps might be sort of flat. They might be sort of quite wide pump stations where you've only got a pump in the sort of centre of it. So what we've always said is, if we can get the correct benching in there and we can get the solids into the pump suction, we've got the opportunity to pump it away. And the majority of the time with the Concertor, we will do. When we've, what we're looking at there, so yeah. So when you're looking at replacement NRVs, etc., you know, one of the things we've identified in the past that the NRV might have failed for some time. Essentially, that means rather than the product being sort of pumped from A to B, it's going back into the sump and recirculating, which means you've got excessive energy. Pumps are pumping longer than they should be doing, just trying to sort of shift that volume of liquid. And then also talking to Yorkshire Water when we've been looking at the benching and the cleaning of it. So they have like a round robin at the moment of actually bringing tankers in to clean some wet wells. What we've been talking about with Concertor, the insights that Avenza gives you, the remote monitoring on that is actually whether we can eliminate some of those round robin tanker visits, whether we can extend the time period of those. A lot of that information is probably not freely available at the moment, but I think as time goes by and Yorkshire Water see the benefits, then yes, you'll see a cost saving for that as well.
Yeah, I think just on top of that, obviously, we have experienced on the sites where we've deployed Concertor that the Concertor pump itself does help to keep the wet wells cleaner. It passes the debris on far better, deals with those rags, passes them through to the areas where we need to take out that, and that's down at the sewage treatment works and the screens. So it doesn't necessarily just keep passing the issue further down the line. So yeah, it's been really good in terms of helping to look to see where we can cut back that cyclical activity of wet well cleaning.
Absolutely, it kind of offers more proactive intervention as well at the earlier stages rather than, like you say, keep pushing it down the line. That's great.
I think one of the final ones is on the gateways. Some of the functionality that you can include in the gateways is actually alter the stop and start levels as the pump each time it pumps down, so that helps keep the sump clean as well.
Great. Thank you very much. Andrew, did you want to comment on that at all before I move on? Or?
It's just good to hear because how you kind of look at this from a system perspective, right? Because if you solve the problem like in the furthest part of the network, you could actually just be moving the problem on, right? So it's good to hear you looking at this from a system perspective, almost like a catchment perspective.
Yes.
Fabulous. Okay, great. Thanks, guys. Okay, next question. I'll go back to the one for you, Simon. So again from John, have you just installed the pumps into existing MCC infrastructure, or have you used the XPC alongside?
So at present, the pumps have been installed into the existing MCC infrastructure. So utilising the existing direct online starter or converting a Star Delta starter to a direct online. With the intention to go back around and ultimately install the XPC or the DP solution at a later date. We're looking to get that planned in and in programme for deployment in the early part of AMP8, which will ultimately mean then we can start to take advantages of those additional benefits that Jason took you through in terms of the Avenza platform.
Fabulous. Great. And just a question from me, really. I mean, it seems like there's a huge list of benefits from Concertor for you. How has it been received kind of by the team at Yorkshire?
Very positively. Yeah, we've took a lot of time and effort to make sure that we've validated the data, because there was question marks around are you sure you've made a 13% energy saving?
Yeah.
And are you sure that it's stopped this volume of reactive visits? So we did take a lot of time and effort, obviously, to go back through the data, look to what it was telling us, and sort of validated that. But also that additional data science exercise where we had some of our statisticians look at the data themselves, and it was quite clear that it was a significant step change that had occurred.
Amazing.
And everybody within the wastewater leadership teams were really pleased about that. Obviously, it was needed, much needed as a business.
Yeah.
But it was good to make sure that that investment had stacked up and was working as we initially intended it to. Really.
Absolutely. Great, thank you. Okay, just another question from Peter, just for anybody who wants to answer. Is Concertor suitable for the transferred SPF stock?
I wonder what Peter means by that. Do you think Peter means the adoptable pumps?
I would probably suggest yes. I would suggest it would depend upon the initial power supply to the station. So the Concertor pump itself is a 3-phase asset. So if the newly adopted site was 3-phase, then yes, I would suggest it's probably certainly the first preference I would look to deploy in that circumstance. If it's only a single phase, then obviously you need to look at an alternative solution, and or even potentially getting the power supply to the station upgraded to a 3-phase supply.
In one of our other water utility customers in the UK, they use Concertor for a lot of their developer services.
Okay.
It's one of the options that they can use, and they tend to use it quite a lot, a good portion of their developer services.
Great.
I was going to say, I think also there's been a number of developers that are actually using the Concertor to start off with, because it reduces the amount of maintenance they're having to do before the station's adopted.
Yeah.
Wow.
Yeah.
A lot of different use cases for it, isn't
Yeah.
there? Wow, amazing. Fab. Okay, next question from Grant. After time when there are issues with the pumps, will refurbishment / remanufacture be prioritised over replacement? And who will conduct the refurb or remanufacture?
Yeah, so in that regard, obviously we've deemed the Concertor pumps to be effectively a more valuable asset. So we've put specific maintenance activities in place to look after these assets far better. We want to try and move away from that, just throw the asset away and buy a new one, because that obviously incurs quite a lot of reactive capital costs to the business that we can ill afford in this day and age. So
Always.
And the strategic stock that Jason's organising for us at our Foxbridge Logistics Centre means that actually we are in a position where we can take out a faulty Concertor pump if need be, refurb it and then drop it back in, or even return it back to their first depot for them to do the refurb on our behalf. So
oh, brilliant. So it is something that you can kind of take a stab at yourselves at Yorkshire to, see if you can do it quicker, and then if not, it gets sent back to Xylem.
Yeah.
Oh, brilliant. Great, thank you. Next question from Michael is, how are you informing the weather info on your SCADA page? How do you do your own local weather measurements?
That's probably answered in 2 ways, isn't it? So I know that Yorkshire Water do their own local weather measurements, and obviously they're looking at where they might be getting flooding or storm events. How Xylem can do it is we'll just take the data from a weather station or forecaster or whatever else, and then we can feed it into events, where we can feed it into Xylem View.
And that weather data could be really important. If we know that there's some heavy rainfall coming along the way, and potentially once we've got a venture installed, we can trigger off a wet well to empty in preparation for that influx of rainfall. Then that can help us in the long term and stop that from actually causing us a flood or a localized pollution incident. And that's part of a wider strategy for the business to help overall in terms of things such as pollution and storm overflows, etc.
I think this is part of the evolution we've kind of tried to get across today, because during AMP8, and if we're going to really meet the challenge of cutting down the amount of environmental pollution incidents they have, catchment management is something you're going to need to consider, and whether prediction is exactly whether measurement and prediction is exactly what needs to feed into it. And I think the thing to mention there is that the data you're getting from Concertor on a station perspective can be inputted into. I mean, various platforms are available. We do one, as but Jason mentions, Xylem View. Can be that data can be uploaded into that, and you can really get a dynamic real-time management of that.
Interesting. So do you think in the future there'll come a time where you can almost have the pumps predicting their own failure based off weather reports in the area? You could get like a warning through saying
I think in the future you're going to be able to make a decision if you know your catchment is at capacity and it's going to spill, you decide where to spill. But up until there is no point, the thing that catchment management does for you is that if you know you have capacity, you manage your capacity. There is if you spill and there's capacity in it, then there's opportunity to manage that better.
Absolutely.
But ultimately, catchment management from the data that these products provide is really the best, mixed with the question around weather measurement, because that's a big impact on it.
Perfect. Okay, and thank you, Michael, for the good question. Okay, so we've got a couple more coming in, which is great to see. So one from Sarah, question for Xylem and Yorkshire Water. Are you looking to develop performance and energy efficiency through the wider network to improve each catchment's performance in relation to the other catchments in the network and eventually the water recycling plant too?
And we maybe just mentioned that the previous answer covers it.
Oh, okay. Sorry about that.
It's a very valid point, right? Because how catchments and how catchments were designed, when they were designed, is very different to how you design it today. But the data being provided, and it's great to hear you talking about your statisticians being able to really, validate the data that's coming back that you're getting there, because there's no point in getting data if you're not going to use it. So I think that type of data allows for that answer to get a solution for.
Not only that, I mean, it helps us in the future in terms of designing future pumping stations as well, because we can take account of all this data, asset performance, asset health data, and make sort of valid judgments as to whether we need to make some changes to our standard pumping station design to take advantage of this. Ultimately, we want to sort of be in that utopia sort of position that you've mentioned there around being able to properly optimize everything, not just the pumps, but everything within the catchment.
Absolutely. Thank you. And then a question from Michael, who just says thank you for the webinar first of all, and how many people are Yorkshire Water actually serving together?
In terms of customers, I think it's around about 4 million people. It's a fairly substantial size company, and substantial size area within the UK.
Amazing, thank you. Couple more questions coming in from Peter, who has asked, has the concept of continual pumping at certain pumping stations been looked into? Been looked at rather than the standard on-off arrangements?
At the moment, no, but obviously the Aventa platform can offer up that capability in terms of being able to operate to a fixed level as opposed to two stop-start levels, but also we can also configure it so it operates to different stop-start levels as well, as Jason mentioned, to try and maintain cleanliness in the wet well. I guess ultimately it'll all boil down to how much in terms of energy efficiency you would obtain from operating to a fixed level set point. obviously these are variable speed drive, but you know, they would have a limit. You would only be able to wind them down so far to meet the static head that they're pumping against. So it's probably one for the future, one for us to maybe trial as a proof of concept and see what advantages we could get out of it.
Amazing. Thank you. Does anybody else have anything they want to
Yeah, the equipment that you've put in, the concerto you put in allows you to do that. I guess it comes down to, as you say, your operating model, but also versus risk, right? You know, the management of the catchment is important. You can do it, but it is a matter of how much, as you say, how much energy saving versus a bit of risk as well. I think.
Absolutely. Thank you. And then a question from PJ, I think for the Xylem team, who says, I'm aware Scottish Water have also replaced their pumps to Concertor pumps in WWPS. Has any European water companies done a similar exercise yet?
So I know the answer to that. I know that it's yes.
Okay.
But because I'm sort of mainly UK based, I don't know which ones. But but yes, you know, if we look at the Concertor is a global product at the end of the day, so we know that it's been used and replaced or replacing other products globally.
Okay.
Yeah, it's well used and outside of the UK as well.
Okay, amazing.
It's quite interesting in actually with Scottish Water. So Scottish Water was one of the companies that we spoke to. Nice joint collaboration and open discussions around Concertor. They've gone about the deployment slightly differently in that they've gone all in with XPC events and Concertor as their solution to deploy all in one hit. Where we've done it slightly different. We've deployed the pumps first and then looping back around to deploy the events afterwards. And that was primarily because we wanted to get after the benefits quicker. We knew that the pump could help us in terms of reducing the blockages, which was our primary goal. And then the secondary goal is to try and get us moving up that maintenance curve that I presented earlier, to get us into that position where we can then start to predict when things are going wrong and visualize when things are starting to go wrong and react accordingly.
The really important thing for us, for Xylem, for us to, you know, to be able to go around stakeholders and the other water companies that we need to talk about and to kind of, you know, get the point across. It's really important that we get data. We've got our own data, right? You know, they're on the flyer, they're on the screens behind you. You know, we have our own data of what we know the product can do. But ultimately, the data from Scottish Water, the data from Yorkshire Water on how many reactive visits you don't need to do, what energy saving you've got, that's really what gives us the information to then present to the rest of the market and say, there's what your return on investment. I mean, you know, as you put on one of your slides, for every £10,000 that you invest in Concertor, you get 14 back, right? And that's a great return on investment. We just need to get the data from the rest of the market so that we can really see, you know, within an AMP period, how much return on investment do you get within that?
Absolutely. Great, thank you. And then just a question from me, really, just thinking that at the moment, a real priority for water companies is how to unlock faster adoption. So do you have any tips coming off kind of the trial into how we can more quickly adopt Concertor as kind of a BAU solution rather than a innovation trial?
Yeah,
I'll say that's that.
Look, I think knowledge sharing is quite key to that.
Absolutely,
really. You know, things such as this webinar, you know, cross industry and cross supplier knowledge sharing is quite key, because then that gives a level of confidence that you're making the right decisions and you're moving forward in the right way with your investment. So yeah, plus, you know, attending you know, water equipment shows or pump centre shows and all these different types of activities that go across the entire year, and just speaking to people, you know, you just get their point of view, just have that open-mindedness, and then have that final ultimate leap of faith to say, yeah, I'm gonna do this, and we'll see what benefits we can get out of it.
Absolutely.
I mean, you need to. I mean, from the supplier, you need to get sponsors within the companies, okay? There are numerous stakeholders, as we've talked about earlier, numerous stakeholders that you need to get on board with that. But it really is around the data, it's events like this that try and really get the information out to people. And Water Equipment Show this year, we'll dedicate the whole thing to the launch of the 6030 and what Concertor can do, and a lot of these kind of case studies from Yorkshire and the other companies will be on there. So it's really about getting sponsors within the water company. Operations people tend to love Concertor, okay, but they're not the people that have got they're not the decision makers, and the people who hold the purse strings.
Yeah.
So it's really getting around the whole business to make them that have people understand what this product can really
Absolutely. Cool.
I think from a supplier's point of view as well, though, it's the industry knowledge sharing that you're doing. So you looked, you approached Scottish Water, United Utilities looking at it, they've approached you, so it's sharing that information as well is key.
Collaboration.
Instead of working in those silos, collaboration has certainly helped us to make the right decisions.
Amazing. Okay. Well, I think that brings us to the end. Thank you so much for all the hard work that's gone in today and for being so open and honest with the learnings and challenges through this project. And thank you so much to the audience as well. We are just going to pop the poll that I mentioned at the start in the chat now. So that is just to let us know how engaging you found today and how likely you are to take action on the knowledge that you learned today. So please do let us know. It's really helpful. It helps us inform our future showcases. The recording for today's event will be hosted on our website. That should hopefully be up in about a week, right, Barry? Along with the written case study and the slides from today as well. So you'll be able to find all of those in one place on the Spring platform, which we'll just pop another link to in the chat for anyone who wants to go and look at that. So yeah, thank you again to the presenters and the behind the scenes team from Xylem, and I will leave you all to have a lovely rest of your day. Thanks everyone.
Thank you.
Thank you.